So yesterday we talked about dictionary, and today we will start with the last data type, and that is set. Okay. Now Python has taken this idea from sets in mathematics. Okay. So before going into Python sets, so we will first discuss mathematics sets. I guess Pratap will be the right person to explain it more details. Let's start. Okay. So if I have one set 10, 20, 30, 40, 50, and let's say I have another set 40, 50, 60, 70, 80. Okay. When I say union, what will the answer? Okay. So it will be combination of both the sets, but duplicate elements will be added only once. I will not have duplication. So 10, 20, 30, 40, 50, 60, 70, and 80. All right. We have something called intersection. So when I say intersection, this will give me a common element between both the sets. So the answer will be 40 and 50. Right. If I say A union B, or if I say B union A, answer will be C. Right. Same goes for your intersection also. If I say A intersection B or B intersection A, answer will be same, because ultimately I'm taking common elements from both the sets, right? Okay. Next thing is A difference. Okay. So when I say A difference B, so it will give me all elements from A which are not in B, right? So 10, 20, 30, 40, 50 not present. So 40, 50 already present in B, so that will be not part of this set. So all elements in A which are not in B. So if I do this, B difference A, the answer will not be same. So now this will give me all elements in B which are not in A. So answer will be 60, 70, and 80. We have something called symmetric difference. Okay. Asymmetric difference B. So this will give me all elements in A and B except the common elements. So answer will be 10, 20, 30, 60, 70, and 80. So all elements except common. So that is the reason if I do asymmetric difference B or B symmetric difference A, answer will be same. Last few things, we have something called subset and superset. So if I take another set, let's say which contains 10 and 20, so as all elements are present in set A, so that is the reason I can say Z is a subset of A, or I can say A is a superset of. Okay. Alright. Now let's come back to Python. So how to define a set? So I'm taking one variable. Again, same as a dictionary. Parenthesis, flower brackets. Okay, and I can start specifying the elements. Okay. Now it looks similar to list also, right? So but now if I say, so what is the difference now? Print S and print type of S. Okay, so this will be your set. All right. So few rules about set. First, all elements should be immutable. Okay, so whatever elements I'm adding, that should be immutable. So the elements can be integer or float or string or a tuple. Okay, so I cannot add a list inside my set. Okay. Next thing, set as a whole is mutable. Okay, which means I can add, modify, delete the elements from this set. Okay, so I can add multiple elements, but elements should be immutable. Okay. Third, same as a dictionary, sets are also unordered. Okay, all right. So when we printed this set S, you can see that it's not printing in the order. So it's printing 40 first, 10, 20 here, 30, 50. Okay. So that is the reason whenever I say unordered, that means now I cannot apply indexing and slicing. Okay. All right. So another important point, okay, all elements should be unique. Okay. So what will happen? Let's say if I add a duplicate elements. So I have this set A. Okay. If I add multiple occurrences of 10, so it will not at all consider the duplicate elements. Okay. So why this is? So internally, how sets are implemented? So sets are implemented as a dictionary only. Okay. So internally, it's something 10. So it should be a key. So whatever elements you are specifying are the key, and the value for this is none. Okay. So this is how internally Python is maintaining the sets. Okay. So that is the reason all rules which are applicable for your keys in the dictionary are applicable over the sets. So that is the reason I cannot add duplicate elements in a set, because I cannot add duplicate keys. Okay. Uh, I cannot add I cannot add mutable elements inside a set, because uh, I cannot set key as a mutable data type. Okay, so all rules which are applicable for your dictionaries, keys in a dictionaries will be applicable over your sets also. That is the reason sets are also unordered data structure. Okay, it's unordered. It's unordered. Okay, so that is the reason if you just print it, you can see it's not printing in the order. Okay, right. It's a mutable data structure. That means I can add, update and delete the elements. Okay. So how to add an element? So we have something called s dot add. Okay. So it will add 100. Again, you cannot specify at what location exactly it will add this 100. If you keep on adding, it's
if you want to add multiple elements,
not possible. So we have few different methods, and we'll come back to this. Okay, so it will take. Okay, so we have discussed all these operations, right? Union, intersection, symmetric difference. Okay, so that will come under your update part. Okay, so let's take the same example. So let's say I have set 1, which contains 10, 20, 30, 40, and 50. Okay. S2 is equals to, let's start from 30, 40, 50, 60, 70, 80. Okay. So first thing we have is, let's say S3 is equals to S1 dot union S2. Okay, so what this will do, all elements from set 1, all elements from set 2, but duplicate elements will be added only once. As I cannot add duplicate elements inside a set, so ultimately I will get only unique elements. Okay. If you see here, so this union method is returning me the third set. Okay, so it's not modifying the original one. So let's say you have one set and you want to update it with the another set, then we have a method s1 dot update s2. Okay, so what is the difference between this and this? So here I am not modifying the original set, but when I say s1 dot update s2, it will perform the union operation s1 union s2 and it will update the original set for you. So update, so it will perform union operation s1 and s2. So because of union, you will get all elements from set s1 and set s2, but common elements only added once, right? So that is my union operation and update the original set s1. But here it will perform the union operation and it will return the result. Okay. That will be added only to the exactly. So you can specify it to the any variable. Okay. So if you want only common elements between both sets, so I can say S3 is equals to S1 dot intersection S2. Okay. So what intersection will do? So it will give me oops. Okay. So now it will give me only common elements between both the sets. Okay. So same variation is available. So let's say you want to perform the union operation and you want to update the original set, then we have intersection underscore update. Okay. So let's say you want all elements from set A which are not present in B. Then I can say S3 is equals to S1 dot difference S2. Okay. So this is the main point you will observe across all Python. So the function names will be relevant to your operations. Okay.
Intersection will go to common elements.
Common elements. Yes.
Intersection underscore update s2 will
again same thing. So it will perform the intersection operation and update the original set. Okay. So here it is returning a value. You can assign it to the third variable. S1 dot intersection perform the intersection and update the original set.
Okay, you will update the intersection with the element which are present only in S2.
No. So perform the intersection operation. So what intersection will give me? Common elements.
Okay.
Now it will update the set S1 with common elements.
With common elements. Okay. Yeah. So it will be like duplicating at the elements, right? Both elements.
No. That means you are getting so in short, you are modifying the original S1.
S1 will be modified. Okay.
In S1, you will get S1 intersection to that. So original set contain these elements, right? 10, 20, 30, 40, 50.
Okay.
You perform the intersection with S2. What your S2 can, so it will perform the intersection. Intersection answer is 30, 40, 50.
Okay.
Now your original set is modified.
So only the common elements remain there in
That's it. That's it. Okay. So now let's say you want all elements from set 1 which are not in set 2. Okay. So it will give me all elements from set 1 which are not in set P. So I have all elements from 30, 40 in set P. So that is the reason it will give me only 10 and 20. Okay. So we have update variation also. So it will be S1 dot difference underscore update. Okay. So what this will do, perform the difference operation and update the original set with the elements. Okay. So in case of difference, your answer will be difference if I do S2 difference S1. Right, but in case of union and intersection, even if I perform S1 intersection S2 or S2 intersection S1, I'll get the same answer. But in case of a difference update, so now I will get all elements which are not in, not I'm printing, just print S2. Okay, elements in S2 which are not present in S1 now.
Right now, S1 difference object S2, create S1. You write similar thing you write.
Which one?
Like in place of S2, you can write S1. In place of S1, you can write S2.
Yeah, yeah.
And then print S1.
Yeah.
Similar thing.
Same thing, yeah. So now I'll get 1020. Okay. All right. So next is symmetric difference. So what is symmetric difference? All elements from S1 and S2 except common elements. So I'll say S1 dot symmetric underscore difference. Okay. If you want update version, we have that is symmetric difference underscore update. Again, it will perform the symmetric difference operation and update the original system. So this is the pattern. So generally, if you see, sets are not used to store the data. Okay. So to store the data, you will generally prefer your tuples or your list or the dictionaries, but you will never store your data in terms of sets because you will not get the duplicates, right? So the only way the sets are mostly used to perform such operations. Okay. So the problem we solved. Let's say I have one list. Okay. 10, 20, 30, 40, 50. Let's mix it up. 60, 50, 40, 45, 80. And let's say 25 and 60. This is one list. I have another list, right? 45, 40, 50, 10, 60, 70, 80. Okay, I want a single list, okay, which is sorted. Okay, um, and it contains unique elements. Okay, so that day we solved this using for loops, right? But the same problem you can try now using sets. Okay, so if you have a list, how to convert a list into a set? So just see s is equals to set. So this is for the typecasting. Okay, so now it will convert to the set. Okay, so what I want, ultimately I want list only. Okay, I want to combine these two lists and I want to remove the duplicate elements. Okay, how you can do this using sets? Try this. Okay, and if you are doing this with sets, you will not need a for loop here. Okay, so symmetric difference in this explain. Okay. Symmetric. So symmetric difference. Okay. So if I have these two sets, okay. So when I say symmetric difference, so this will give me all elements from set A and all elements from set B except common elements. So it will not give me 30, 40, 40 and 50 because it is common in both the sets. So all the elements except your intersection operation. It's kind of so if I do intersection, I'll get 40, 50, right? Yeah. So in short, it will give me all elements apart from the elements from your intersection set. Okay. So that's the difference. That is symmetric difference operation. So it's like these are my standard mathematics operation. It's just Python trying to implement the same thing using functions. Yeah, should I write? Yeah.
Can we convert the set to list right?
Yes. Yes. So if you have one set, yeah, okay, tell me.
Again, if S is set of L1, right?
So okay, so just make it as S1. S1 is equals to set of alpha. Alright.
S2 equal to set of L2.
S2 is equals to set of L2.
S1 dot update S2.
S1 dot update
S2.
S2. Okay.
Another is print S1.
So now my S1 is already modified and I'll get all the unique elements. Okay, but I want a list. So let's say L3 is equals to list of S1.
L3 dot sort.
Let's say L3 dot
Sort.
Right? Because I cannot sort it first, because if I convert it to the set, it will defaultly change the order, right? So in that case, my sorting operation should be lost. Okay, so I'll get the sorted order. You can.
So the duplicates they can sort it directly.
No. So I don't have duplicate, right? So the once I convert it to the set.
I mean, after converting, obviously in same situation.
Yeah. It's so it will.
These you can do. I mean, if duplicates are there, directly you can sort.
Yeah.
So what is the usefulness of transferring to set from the?
So if I want to remove the duplicates from list, so we have discussed that I need to write a for loop logic. I need to take another list. If it's not duplicate, then only add it to that list, right? So I'm saving my one iteration, entire iteration operation. Okay. And so we can do one more improvement here. So here we are converting it to the list, and here we are sorting it, right? Remember sorted function? Okay. So if I do sorted of S1, so for sorted, whatever data type you will pass, it will sort it and defaultly it will return you a list always.
So sorted works on all data types?
All data types.
Yes, output as list.
List. So ultimately output will be a list. Okay. So generally you will find the use cases of set that whenever you have a list of multiple data, if you have a problem where you need to remove duplicates or select elements from this list which are not in this, all sort of problems you can solve converting to the set. Okay. So so sets are generally not used to store the elements or to store the data, but whenever we have to perform such operations, instead of writing a for loop logic, just convert it to the set and take advantage of this union intersection functions. Okay.
Why it is avoided from storing data?
Because you cannot store duplicates. That's the only thing. Okay, so you'll never find that you are accepting input from, let's say, file and you're directly storing into a set. No, never. All right, do we have a set? Yeah. Okay, so we have something called pop, we have remove, we have something called discard, clear is also there. Delete. Okay, so this is my set. Remember pop item operation?
Index.
What this will do?
Remove.
Can I specify the index for a pop item? So for first of all, pop item is for which data type?
Dictionary.
Dictionary, exactly. So can I specify a key to remove using pop item?
It randomly deletes.
Exactly. So your pop item will randomly pick one key and the value pair and remove from the dictionary, right? So the pop works similar here. I cannot specify the element. So defaultly it will take any element from the set and it will remove it. Okay. So you have to be cautious. Okay. So it will pick any elements. So this time it's picking the first one and remove from the first. I cannot specify the element. It will throw main error top text, no arguments. One is given. Okay. So this is first. All right. Then we have something called s1 dot remove.
Now one question. If we want to normally sort, we have to sort it from ascending order, from smaller to higher. Is there any function for descending order?
For descending order, I don't think so. Because even if you do help of sorted, let's see, do we have any attribute? You can reverse it, but oh yeah. So it's that reverse equal to false. So let's say this is the list. If I say 45, 85, 20, 45, 63, 10, 5. Okay. If I say L2 is equals to sorted of L, I need to say reverse equals to Okay. Also descending order. Right.
This is false, strings ascending order.
This one? Yeah, reverse is false. Defaultly this is false. So defaultly this is false. If you do not specify, it will be ascending order. So when I say reverse equal to true, it will sort in a descending order. Okay. All right. So we were at remove. Right. Okay. So you will specify element. It will remove it from the set. We have something called discard also. Just have a look and tell me the difference. So I'm saying 50. Throw this in. Okay. So this is also removing 50. This is also removing 50. Any difference?
This one works only for sets. Or it is in order.
Okay. So if I try to remove something which does not exist, this will throw me an error. But on the other hand, discard will simply ignore that particular element. Okay. I guess clear, everyone knows. You get a empty set. And lastly, we have this.
This can work on other data types also.
Which one? No. These are specific to sets. Okay. So it will remove it from memory and I cannot reference it after. Okay. So these are your set operations in Python. So for type conversion, we can use this set function and you can convert any compatible data type to set again using this particular function. So you have a list, just specify a set of that particular list and it will convert. If you actually have a list, you can convert it to the set. If you can interchange both things. Okay. So typecasting works for this, but you cannot typecast it with integer, obviously. It will throw an error. Okay. So if I do this, okay, it's not iterable. So it needs something which is iterable. So I can even specify a range also. Okay. So this will generate a set format. Okay. So that's all about sets. So this is the last data type.
What is frozen set?
Oh, we don't have anything like this in Python. Just control Z. Oh, you said frozen set?
Yeah.
Alright, okay. So if I am not wrong, frozen set is something, it's like whenever I define a frozen set, I don't think I can change the value of it. So let's try this. So whenever I say this is equals to set.
Frozen is frozen.
It's frozen.
Okay.
So frozen set of this 10, 20, 30, 40, and 50. So if I something like this, if I say print this,
It's not different.
mm, just try this. Right. Okay. So on this set, I don't think I can perform any methods. So just try this first. Help of frozen set. Okay. So I will have union operation, symmetric differences, superset, all this. Okay. But you can see I don't have this update operation here. Okay. Copy is there, but we don't have this add method also. So this is the immutable version of your set. So now once I define this, I cannot say s dot add of 70. Let's try anything. As new attribute. Okay. So all the methods, even we have this union intersection method. So it is present, but I don't have the update version of it. So let's see this version set of 70, 80, 90, 100, 200, and 300. You can say S3 is equals to S1 dot union S2. Okay, so this will work. It will return a third set. This is also again a frozen set, but I cannot perform the update operation. So we will not have something. So for union we have update. It will not work. Okay, so all the update versions will not work here.
So frozen set can be operated upon only with frozen sets.
Not necessary. Not necessary. S4 is equals to S3 dot union S4.
This one.
Yep, it's okay.
And the type is a frozen one or is
Yeah, so for this it should be normal. It's normal. So if both of them are frozen, then only, or let's try this one. If I say S1 and S3, yeah, so it depends on this set. No? If this is a frozen one, I'll get this frozen set. If this is, so if I change it to this, let's change it to S1, everything.
Frozen means basically passive. And IDs can be.
Yeah, so I cannot change the value of it now once I define it. So it's like a tuple of sets. You can say. Because all my sets are hashable, so my normal set is also hashable, and frozen will also be hashable.
So then what is the difference? Like you said, in set, these are like keys.
Mhm.
Keys are also not possible.
No, keys are hashable.
Yeah, so
Keys are hashable. Yeah, everything is. So set is enter hashable.
so
So that's the only thing. So we cannot add unhashable types here. So when we say list, I cannot add inside a frozen set or inside a set. It just when I define a frozen set, now I cannot modify this. It's the same as exactly same as my tuple. I define it, I cannot change it now.
So there is no deletion of any.
Yeah, yeah.
can you transfer like from sets to frozen set?
Yes, yes. So this is my frozen set. So let's say S3 is equals to set of S1. Okay. So I'll comment this out, and now let's set the type of S3. So this is my original set. My set I from frozen I converted to normal set. So that is possible. Any more queries?
Scenarios will be using frozen sets.
Not much. Not much. Because ultimately, the main reason we want to make it not updatable is while passing values between from one function to another function. So all these things. For that purpose, I guess the best suited thing is tuples. So I don't see any much more advantage using frozen sets.
The people also you can change to list and you can
Yeah,
right that way.
that is fine. So if you have a tuple, so you can just see L is equals to this stuff. This is type of file. Okay, this is okay. Right, so these are the data types in Python. So as most of the books are absent, so we'll not start from function today. Okay, so from tomorrow we'll start with functions in Python. Okay, so functions and different ways of passing values between functions and everything. Okay.